electric.
Hi everyone, welcome back for another video. Today I want to talk about our air-to-air heat pump heating system. So yes, we've gone for a Toshiba Haori, I think that's how you pronounce it, air conditioning system, but it heats as well. So it's got the same sort of heat pump, the compressor outside, as you'd have with a wet system radiator, air source heat pump. But we have, instead of heating water in the radiators, we're heating the air and blowing warm air out of the units on the inside. Why have I gone for that? Well, I did a video talking about the quotation that OCTOPUS offered me for an air source heat pump. And the more I looked into air source heat pumps, the more the price was more than twice of implementing the air-to-air system. So instead of $5,500 that I've spent on the air conditioning, air-to-air heating system that we put in, I needed to spend $10,000 to $12,000, maybe even up to $14,000 to put an air source heat pump in onto the radiators. Upgrade all the radiators, change lots of them, change the microbore pipes that's there, and have an oversized air source heat pump outside as well. The amount of excess that was going into the quotations I found ridiculous, and it didn't suit what I wanted from a heating system. And I know it sounds a bit simplistic, but I really just wanted like a 6 kilowatt air source heat pump tacked on to the existing radiator system instead of the oil boiler that we've got here now. So I wanted a minimal implementation. I wanted to do the sizing myself. I know roughly what the heat in the house is needing. I know what the leakage of the house is roughly. I've had enough quotations, done enough estimates to know those values. But you just can't get that. Installers don't take any of those risks. They love to do more than what's actually required, implementing loads of things for scenarios you're not going to account for. You know, they're going to install radiators that want to have your rooms up to a temperature that I don't want to have, but they have to do it because they have to do it to meet standards for the grants. So have the implementation of the grants overinflated the prices, which is putting me off. I guess that's part of the issue. But also it's because I don't like radiators. Like in this room, there's a radiator behind me, and I can't use this wall in the kitchen for anything else because there's a radiator there. Once we get rid of the radiator, that can become a nice unit area. So getting rid of radiators is a good thing, and having the air conditioning units higher up on the wall frees up space. The sofas in the lounge can all push back, etc. And you haven't got heaters behind them. So there's a lot of benefits for the air-to-air. But also, what really happened was Susan was saying to me, I love air conditioning. We had some portable air conditioning units in, and she liked it so much in the summer that she said, let's have proper air conditioning in the house. So she was happy to spend the money on what we've installed just for the air conditioning. I was happy to spend the money to install what we installed just for the heating. So it's a win-win. So that benefit of getting air conditioning in the summer, free from solar energy, plus the heating capability, meant it was much better value as a solution than going with an air source heat pump that connects to the radiator system. So for us, all of these things were just adding up that air-to-air is the right way to go. So that's why I've gone for an air-to-air system, because I wanted the heat pump, I wanted the efficiency, I wanted to go electric with heating. I don't want gas, I don't want oil. The oil boiler smells with the oil, and the oil tank is a risk of contamination into the ground if it leaks. Our insurance company almost didn't insure us for the home insurance because of having an oil boiler, and they normally don't insure people. It's only if you have car insurance with them as well that they would take it on, which, you know, all these things just add up. Having oil is just not a good thing. Plus also how we use our heating. We're not the sort of family that turn the boiler on and then the whole house, every single room heats up, and we don't leave it on 24 hours a day. I know some professionals will tell you that's the way to go. Well, it might be for efficiency of the boiler, but it's not necessarily the most efficient way of reducing your heating bills. We're most certainly finding that we are massively below the average cost, the average number of kilowatt hours for usage for heating our home, because we don't heat half the rooms in the house. This kitchen doesn't normally have heating on, our spare room doesn't have heating on, the spare bedroom doesn't have heating on, and the bathrooms don't always have heating on. Those are all independent from the air-to-air system that we have, and we turn the heating on in those rooms when we need to. So the way we use our heating system here is more economical than leaving it on permanently and just having a single thermostat switch in the hallway, for example, on the old boiler system, and just turning it on and leaving it on. I think when we used to use the oil boiler, we used to use about 500 to 600 litres a year, whereas some people will get through a tank or 2 tanks, you know, a couple of thousand litres. So people's usage of energy is completely different, and it's not just dependent on their type of home. This is a 15-year-old home, well insulated, modern home. But people use heating for their own comfort. Some people are turn it on, leave it on because they want to have it warm the same temperature whenever they go into the room. Even if they're only going in for 2 or 3 minutes for the day, they still have the heating on in that room all the time. And, you know, each to their own. If that's what somebody wants, if that's what somebody deems as being comfortable, then that's up to them. For us, we're quite happy to have rooms that are colder, rooms that are 12, 13, 14 degrees, and you don't go in them very long. And you don't stay there because it's not as warm and it doesn't detract from the heat in the other rooms. So everything pointed towards an air-to-air heating system suited our requirements. But what did I go for and how did I design it? Let's talk about that. The first thing was I did a previous video looking at electric heating, and I looked at where to put the oil-filled radiators that we used as a temporary heat source and how much energy, kilowatt hours, we used in each of the rooms to heat. And it was obvious that it was the lounge and the hallway, the central core of the house, and the main room that we spent most of the time in during the day. Those are the two areas that we needed most energy, most radiators. So that's 2 rooms that we definitely needed the indoor units for this air-to-air system. So it's where to put the other 1 or 2 units. Now we did think about the kitchen, because the kitchen is brilliant for air conditioning. In the summer it gets really, really hot. We've got a lot of glass windows here in the room, so air conditioning in here would have been brilliant. But we don't have the heating on in this room, so to have a unit in there which is only used for air conditioning was a bit of an excess, so I wasn't really happy about putting the unit in here. Plus the location of this room meant the pipe run was really, really awkward. And it probably would have meant installing a second condenser unit, compressor unit, whatever it's called, the heat pump, a second one outside to handle the kitchen separately. So it was a lot more money, it was a lot more awkward, there's more visible pipe work, and it didn't need it for the heating. So we didn't go for it, we didn't put it in the kitchen. The other one was our main bedroom. We wanted air conditioning in there especially. So we deemed that the bedroom was going to be an essential for the air conditioning. So we did put a unit in there, but also that means we can have heat upstairs as well. So we've got an air conditioning unit and an air-to-air heating unit upstairs. So if we open the bedroom door, we can actually heat our room and heat the whole of upstairs with that one unit, turning the fan up and pushing the air out. So that made sense. So that's 3 units we went for. The system that we installed could be installed as a 4-way split system, but we actually only installed those 3. We couldn't find another room which justified sufficiently for both the heating and the cooling effect, without introducing some very awkward pipe runs. So for us, we went for a 3-unit split system with an 8 kilowatt heat pump outside. Now I thought it'd only need to be a 6 kilowatt, but when we had the quote come through for 2 3.7 kilowatt units on the inside and 1 2.7 kilowatt on the inside, the installer wanted to put a 10 kilowatt heat pump outside to meet the demands of those units. And I said that was excessive. We looked into the actual power requirements, the wattage that would be used to drive those units while heating or cooling. And I saw those figures were too high. So I asked the question and we sent it off to Toshiba to say, you know, what would the wattage power difference of those units be different if we went down to an 8 kilowatt unit? And it was significant. It was a significant drop. And I guess it would have been another drop. I don't think it was as big a step, but it would have been a step further down to 6. So I talked to the installer about, you know, the impact of having more powered units inside than what the heat pump could provide from the outside. And he said that it'll all work, it just takes longer to heat up. So all you've got is a longer delay. Well, I didn't mind that. I didn't mind having a few delays on getting the heat going because it doesn't have to be instantaneous. So I was happy to go with that compromise, but I sort of wimped out of going with the 6 that I thought we could have got away with, and I've gone for the 8. Turns out that we've got a really good compromise because it is quick to introduce the heat, and I do quite like that. But equally, the power requirements are really low. When it ticks over at 300 to 400 watts. On days where we've had minus 3, 4, 5 degrees this month, it's actually been ticking over at 5 to 600 watts, which I was really impressed with. That to heat the whole core of the house and our main heating needs at just 500 or 600 watts in the coldest of temperatures. That's what I was looking for from the system. So when you're looking at the heat pump power capability and then you're looking at the power capability of the indoor units, those things don't really, they're just numbers, they're just peak numbers of what it can achieve. What I'm interested in is how many watts is it using while it's on, because I want to match that to our battery and to match that to our solar capability to try and make it as economical as possible. And that's something I've got to say right up front. I am absolutely loving this heat pump system because it ramps up and down really, really slowly. So it starts in at 20, 50 watts, and then it's 60, 70, 80, 90, 100, 150, 200, 210, 220, and it just keeps going up in those slow increments until it's getting up to, even up to 1100, 2200, but it goes up small. There's no big jumps, there's no big peaks. And that's perfect for running on battery. You're not getting any ramp up and ramp down, and you're not getting any grid draw. So very, very efficient and perfect for a solar and battery installation. Absolutely loving it. So anyway, I sized the units based on everything matching: the amount of solar we have, the amount of battery we have, the power draw that I wanted to see. The maximum power draw from the air-to-air conditioning systems, in theory, is 3.8 kilowatts. That is capable of just our battery. So I could be running in the evening with no solar, no grid draw, just from our battery, from our Victron and Pylon-Tech batteries. So I've sized it to be able to do that. But in reality, unless you turn it up to the absolute maximum and the absolute maximum high power settings, you don't get up to those 3.8 kilowatts. I normally see it peak at 2.5, 2.6 kilowatts. So the heating system is well within the draw of energy that I wanted from our solar and battery. So I'm really pleased with that. It's all, I've been able to design this to match the size of the house and my requirements and the battery and the solar. So it's all part of a good plan, not just what an installer wants to throw in. And that's what I really wanted to avoid. I wanted to avoid having something that was meeting regulations, meeting requirements, what an installer recommends, but not what I wanted. So the biggest problem that we had with these air conditioning units is hiding the pipework. The first quote we had was from a guy that was quoting something like £10,000–12,000 to install it. And all he kept going on about was how trunking was so difficult to get hold of and it was so expensive, and did I want it? He was happy to put pipes and cables highly visible on the outside without the trunking, and was trying to put me off trunking because it's so expensive. And half the time when we talked about, for example, in our hallway, we wanted to have it in a central location downstairs so we had the best heat and cooling effect. But because of where the compressor unit was, which isn't in the centre of the house, it's on the outside of the house, we had to run the pipes in a way which would have been awful on the inside. So he was recommending that we actually put it on the staircase, so it was closer to the wall where the outside unit would be. Now, that was great for air conditioning because you could push the cold air down and that would work. But for heating, I didn't want to have to force the air down the stairs with a lot more draft, shall we say, to achieve the heating. So everything that this installer was telling us was that it couldn't be done. We couldn't put a unit here and we couldn't run the pipes there, and it was all very negative. So we didn't go with him. I didn't get the right vibe. I luckily found a great guy called Graham from Ignite Heating and Cooling over in Great Yarmouth. He really is a professional. He really is an expert with these sort of units. He mostly installs Mitsubishi heavy industry units, as well as the Toshiba units and all sorts of other brands, but mostly the Mitsubishi is what he prefers. But everything that he talked about was all possible. He could do it. He could find a way of achieving the design that we wanted. But his emphasis was always about, it was him that was saying, but I'd have to hide the pipes. We couldn't have them visible. And that was what convinced us to go with him on how he was going to hide the pipes. I mean, I look at installations like this. I'll show you an image now of a heat pump installation. And I see this. Someone was proud to post that picture of, they've implemented a heat pump, but it just looks awful to me. The pipes and the cabling being so visible. And that's what we wanted to avoid. We wanted to avoid the ugliness of cables and pipe runs, both on the inside and the outside of the house. The hallway one was the big challenge because that had to cross the house in some way. So we either had to interrupt the ceiling to get the pipes out to the other side of the house, or we came up with the idea of going through the hallway into the kitchen, through the kitchen to the outside of the house on the wrong side of the house, cables and pipework up the wall, into the loft, all the way over the loft, down into the compressor unit, so complete all the way round. Now that sounded awful to start with, and it's the sort of situation where I wanted to just get out of the house and leave him to it and come back and find it all done. You didn't want to see what was really going on. But he explained, no, he could put it where the ducting was for the oven hob extractor unit, so we could hide the pipework up in the same place there, and we could pop it out where the extractor pipes are outside. You would hardly see them, and his way of hiding the pipework outside was to use drain pipes, waste pipes, to hide them all in and put them next to the existing drain pipes that you have, and that way you hardly notice them, so it actually looks like part of your drainage system. And that's what we've gone for. We have one on either side of the house. They really are a clever idea because it hides it so well that only when you're standing close to it and you look up and you realise what they are, you can tell that it's actually ducting for all of these extra pipes. From a distance, it just looks like the rest of the pipes that's already there. So it blends in really well. So again, Graham was absolutely fantastic with Ignite heating and cooling because he wanted that professional job where everything was hidden, and that was really what we wanted as well. So he managed to put the unit right in the centre of the hallway, which is where we wanted, and that means we get the best effect from both the heat and the cooling. And that has worked out perfectly. He did the same in our bedroom. We had a choice of 2 locations, one on an end wall right next to where the compressor unit was, so that would have been easy for the pipe runs, or one in the centre of the room, which then meant the fans could blow the air out with an open door just behind us. Would then be able to get the heat and the cooling onto the rest of the upstairs of the house. So I wanted the location centrally, not over by the wall. So again, he's gone up into the loft, and pipework's then gone across and gone down to the compressor unit. All hidden, all implemented really well. And apart from the drilling, the drilling and the size of the holes that are cut in your house is, yeah, they're big, but they are with a heat pump system as well. They are with anything. And it's just perfect now it's done, that it's all hidden and you can't see it. But yeah, while it was going on, it's a little bit, wow, another big hole going in the house. So that's our design, the 3-split system with the 2 larger units downstairs and the smaller powered unit, the 2.7 kilowatt upstairs. We went for Toshiba and Haori because I knew of its web and internet capability, that I could definitely control them online. I was also familiar, I've used them in my previous IT profession previously for cooling a data center and a tape storage room. Yeah, magnetic tapes, eh? That takes us back a bit. Anyway, so I've got experience of using them for several decades, an extremely reliable unit. So I trusted Toshiba units based on the reliability, the price, the power capability. And the big one was that Toshiba, actually the support side, came back and gave us the wattage figures. Mitsubishi wouldn't do that. They couldn't get into that level of detail where Toshiba could. They could tell us their estimated profile of what all the wattages would be in the different modes. And that really did convince me to go with the Toshiba. Yes, the Haori ones are a little bit more expensive, but they're a nicer design. And they've got a nice fabric cover on the front, which makes them look less industrial, more like a white goods item and more like a piece of furniture. So I'm very impressed with these Toshiba units. They don't look too big. I'm very happy where they are. The fan noise is really quiet, especially when they have a whisper mode as well. You can hardly hear them at all. So if you're worried about an air-to-air system because they're going to have a fan and air blowing, well, the great thing is you can divert the air in any direction you want, left and right, up and down. So you can divert it away from where you want to be, but also you can have it on such a silent, quiet mode. It just trickles out, and basically, yes, there's not as much heating or cooling power while it's doing that, but when it's in tick over, that quiet mode is absolutely fantastic. Talking about the quietness, I've measured the decibels outside, and our oil boiler was noisier outside than the compressor unit is for this air-to-air system. We had our neighbours around just the other day, and I asked them, have they noticed the compressor unit? Have they noticed the noise? Hadn't heard it at all. So anyone's concerns about heat pumps and compressor units and whether they are noisy when they start up and whether they wake you up in the night and that sort of thing, quieter than the gas or oil boiler that you might already have. Incredible. Right, let's talk about one of the problems with these units. Something that I hadn't really thought about until we got into the implementation side of things was the drainage for the dehumidifying side. So when they're in cooling mode, they dehumidify, they capture the moisture from the air and they put it out into a container unit inside the indoor units. but that needs to drain. So if the unit's on the outside wall and you've got a drain area where you can drain it to, you can just drip it outside and have it go straight outside, straight into the drain pipe. So on one side of the house, one of the units goes straight into the drain pipe. But our hallway is in the centre of the house. So how are we going to extract the moisture from there and get it outside and put it into the drain? So you need a pump, and these units have very small micro pumps that are supposed to be silent. And we did have some issues with two of the units and putting these pumps in that I could hear them when they came on and extracted the water, and they come on every 5, 10, 15 minutes, something like that, and it just extract what water's come out and dump it outside. They're supposed to be silent, but I could hear it, and I could hear it vibrate. So we had Graham back, and he tried several different makes and types of pump, and mostly it was to do with the leads, not the actual pump itself. It was that the leads were rattling, so that there was not enough length of the lead to get it into a place where we wouldn't be able to hear it, or too much of a lead, so it was all lumped together and that cable was vibrating inside the casing. So anyway, we experimented with a couple of pumps, and he put one of them actually up into the loft, outside of the room and outside of the unit. That meant we couldn't hear it at all. And the hallway one, we've actually moved it across into the kitchen. So as I said, in the unit in the hallway, we've drilled through into the kitchen, and all the pipework goes further away. It's actually inside one of our kitchen cupboards. So it's completely out of the way, and can't hear it. So these little mini pumps to extract the moisture can be an issue, but they're only needed for units where you don't have a direct output to the wall. So it's only where you've got difficult cable runs and you're putting these units in the middle of the house. That's where these little pumps are required. But I can confirm, if you get the right one, they are absolutely silent, and you can place them in positions where you can't hear them whatsoever. So in heating mode as well, it's not needed because it does not dehumidify while it's heating. Great thing about these units, yes, they heat, they cool, they purify the air as well. There's a feature on it for that. It's filtered air with plasma something or other, which it does to the air to make it clean and tidy and get rid of the odours. Gotta say, it does feel nice. I've noticed since having these units, we don't open the windows as much. So I used to open the windows all the time to air the rooms and have fresh air come in. Don't seem to do that as much anymore. We don't have as much condensation, we don't have as many air issues. I don't feel the need to open up as much, and hence we've got better efficiency as well, not letting the cold air in. There seems to be lots of benefits for having the warm air system rather than a warm radiator. No bad smells, no creaking of pipework, no creaking of anything. I think a much more silent system. The heat just feels really comfortable, and even when you have the fans on a little bit more, come downstairs in the morning and you're like greeted by a warm waft of air as you come down. It's really, really pleasant. And then being able to control the direction of that air and the force of the air, when we're doing laundry on the inside and drying it on the inside, we can actually turn the fan on that unit up, and it's helping to dry the laundry even faster with a dehumidifier unit to get rid of the moisture. So there's a lot of pluses, and you can't have all of those things if you have the wet radiator system air source heat pump. So yeah, I'm very, very pleased that we've gone that route. It was absolutely right for us. I think the important thing is to go electric. The important thing is get yourself a heat pump because it's using less energy. But the design and the implementation, just like it was with the solar panels, is the key. Get a good installer. Don't get the sort of installer that I had to start with that just said everything was difficult, everything was expensive, can't do this, can't do that. So how are we using the system? Right, we don't run it continuously. So basically at about 4 o'clock in the morning, I have them fire up on a timer. So there's a schedule set, and I have them set on silent mode. So it's not on full power, it's on a lower power rating. It consumes about 1 kilowatt when it comes on at that time. Then as the time approaches 6:30, I take the silent off, and then we go up to more full power. But most days, even in the silent mode, it's got the rooms up to temperature. We don't really need to. It's only when it's been really, really cold into the minus levels as to where that 1 kilowatt of heating hasn't been enough to warm the house up from 4 o'clock till 6 o'clock in the morning. So we use that period to boost the temperature of the house up to 19 to 20 degrees, and then it goes off. And it goes off until there's some solar. So basically it goes off until about 9:30, 10:30 in the morning, and then it'll come back on again. And that's the time typically we'll go out and take Cracker for a walk. So the house is warm while we're getting up, it's warm when we're having breakfast, it's warm when we're going out. When we come back, it still feels warm, but then we can put the heating on for when we're settled down for the afternoon. That's how we use our heating system. And it goes off again probably around somewhere between 5:30 and 7:30 in the evening. We turn it off and then the temperature will start to reduce overnight, ready for the next boost the next day. Charlotte's the only one that's different. Her bedroom, she'd love an air conditioning unit, but the way she uses heating is completely differently. She gets up at a different time to us, she's out at work and comes home at different times, so she needs heating at different times, and hence we haven't put an air-to-air heating system in her bedroom. We've given her a separate electric radiator, and we have that on a schedule, and that's scheduled for when she needs it. At the same time of installing our air-to-air heating system, I also got the guy, being a plumber, to install immersion heaters in our bathroom radiators. We've got a bathroom, an ensuite and a cloakroom. Those all had radiators onto the oil boiler. They've now been disconnected from the oil boiler and just have an electric immersion in them. So they've still got the same water in the radiators with an electric immersion element inside the radiator that's on a smart plug. And basically they come on and off, boosting in the morning and staying on during the day when we want them off. But they go off a lot of the time as well. I don't leave them on permanently. We don't have our bathroom heating on 24 hours a day or even throughout the entire day. When you get up and wanting to use your bathrooms, it's nice to have warmer towels, dry towels. And that was the key for the bathrooms, that you needed a heating source that can keep nice, warm, crisp, dry towels. Without a radiator, that's much harder to achieve. I tried with an infrared panel. I didn't get the results that I actually wanted. So I did want to keep radiators in our bathrooms, and that's what we've gone for. Just 250, 260 watt elements in each of the radiators. Got to confess, the cloakroom one for 250 watts is overpowered. It reaches its thermal cutout at about 70 degrees too quickly. So the big one, how much energy are we actually using? So I'll show you a graph here of the energy we're using with the air-to-air heat pump. And it's not a lot. On a day like today where it's 7-8 degrees outside, the heat pump is working really, really well. Great efficiency. Probably 5-6 kilowatt hours of energy, including the boost in the morning, is all we need to keep the house warm for our requirements. For somebody that wants it on all day and use it all the time, it'd probably only use 9 or 10 kilowatt hours. So we're making a saving because we haven't got it on all the time. On the days where it's been freezing at -4, -5, those worst days in December so far, the most we ever used, I think, was 13 kilowatt hours for that system. So I did want to try it and make sure we used it in the worst conditions to see how it actually worked. But 13 kilowatt hours is just such a little amount of energy. Now, okay, it's not all of the rooms. You've got to add in the extra immersions for the bathrooms that we use and Charlotte's bedroom, those sort of things. But 13 kilowatt hours for the worst, when you look at an average for a house of this type and the average kilowatt hours that people are using with a gas or oil or other systems, and you're talking somewhere between 50 and 60 kilowatt hours is considered the average for heating a home like this, which just seems excessive to me. And I think it highlights the route I take of not being cold, not being a miser, but just being considerate that what's the point in heating a room that I'm going to spend 2 minutes in twice a day and heating it all day? And if you multiply that by that room, that room, that room, and that room, it really adds up that excess of heating them for those few times you go in there, is it really worth it? So it does depend on how you use your house and how you use your rooms. But when we're down to just 13 kilowatt hours, somewhere between 6 and 13 for our main heating source, it's absolutely negligible. And again, worked out brilliantly with the size of our home storage battery. We put in a 17 kilowatt hour battery, usable 14.5 kilowatt hours roughly. And that is enough to last us through the night. We haven't gone beyond, I think 36% is the lowest I've been with the battery so far. So we've still got some more capacity, which means there's more heat, there's more energy I can use during the day. We don't have to be thoughtful of, got to turn it off to save the battery because we don't want to use peak rate energy. None of that sort of happens. There's plenty of capacity to do what we want and use the heating when we want. If we ran it 24 hours a day, On a absolute freezing day, of course, we'd run out. We need more batteries, but you'll always want more solar. You'll always want more batteries. So I'm happy with the level that we've got, that the heating system provides the heat we want, even on the coldest of days, with no solar as well, only using cheap rate energy, using our home storage battery. That's the aim, that's the design aim, just cheap rate energy and the minimal amount of energy as well. But overall, I think our worst day so far has been low 20s, 21, 22 kilowatt hours for the entire day for every heat source in the house on the coldest of days. And yeah, very, very happy with that. Problem is that it's so good, I haven't really been using up the oil boiler. We've got 400 litres of oil left in the tank that I want to use up and get it emptied so that we can decommission it and get rid of it. But the air-to-air heating system is so efficient and so good. I haven't even in the darkest of the winter days that we've had so far in December, I haven't really felt the need to put the oil boiler on. Well, I can say I haven't at all. I have not felt the need to put the boiler on. It has been a success with our electric heating. And because of that, I just haven't wanted to burn the oil, and I don't know why, because it should be free and it makes the stats look better and all those sort of things. It must just be that I'm trying to test it to make sure I have a clean month with just electricity usage. It's quite annoying that I want to use the oil up, but I'm not finding the days when I want to. Today would be a good day to have the oil boiler on. There's no solar. It's going to rain absolutely all day. It's only 6 degrees or 8 degrees outside. You know, it's nothing bad. But I've got a full battery of really cheap energy that's been charged up overnight. So if I use the oil boiler, all I'm saving is the cheap rate energy. It's almost as if I'm waiting for that day where we need the heating overnight, but we never need the heating overnight. So yeah, I've got to use the oil up sometime. So if I don't throughout the Christmas and the New Year period have the oil boiler on, it'll have to be January. We'll have to start turning it on in January and use that up. The other thing is we do have another heat source. We have a log fire, a log burner, which I know some people hate, but it really is a good supplemental heat source for on the worst sort of days when you don't have any solar and you don't want to use peak rate energy. They are very, very good. But what I've noticed with this heat pump system, the heating is so effective and we've got so much stored energy in our battery that I haven't been using it. We have not used our log fire as much as we did last year. Not just because it's been milder, it's just significantly less use. So it really does please me that through going with an efficient heating system, the heat pump system, it's probably going to be the catalyst that we're going to be able to let go of the log fire at some time and de-implement that as well. I don't think that'll be immediate. I think that'll be something that we'll keep for a few years yet, as well as a supplemental heat source or even as a contingency heat source, but it's going to be used a lot less. Do heat pumps work in winter? Yes, they do. Up to -5 so far I've experienced no problems whatsoever. A couple of defrost cycles is all you get, a couple of interruptions in the heat source, and they just work brilliantly, and they still provide very efficient use. So it's not as if you get to like -5 and suddenly you're burning huge amounts of electricity to keep warm. It's just not the case. The heat pump works brilliantly. So whether it's a heat pump on a water system or the air-to-air system, I don't think it really matters. Heat pumps are effective in the UK, even in negative value temperatures. Yes, you use more energy because the COP value is worse at those lower levels. I really have noticed, even at tick over, you can see it at 500-600 watts, maybe even up to 800 watts, where if it was a milder day, it would tick over at 300 to 400 watts. So, you know, I am seeing like a doubling of the energy use at the times when it is like -5, etc., compared to when it's +8 in the more autumn and milder days. But that's acceptable, isn't it? You know, whether we're using a small amount or a larger amount, all you have to think about is how many days is it -5 in the UK? And there aren't that many days of the year where it is. So the number of heating days that you need that are that bad, there aren't that many at all. So it's acceptable to have that higher cost when most of the other days you're going to get a much higher COP value from a heat pump. So yeah, I think heat pumps really work in the UK, and I think we should all be doing it. I do agree with the implementation of heat pumps. What I don't agree with is Is the design moving away from what the customer might want and might find the most economical to what an installer thinks is the most effective way of doing things and what they have to meet for their regulations, etc.? It's just an absolute overkill. We're installing far too powerful systems. You know, they haven't learned their lessons installing overpowered oil and gas boilers, and now they're putting oversized heat pumps in that just aren't really necessary. With radiators, they're going to be too big again for most people's heating needs. So it's a shame to see that excess still going on, still driving higher priced installs, where what we want is lower priced installs to encourage more people to do it. Anyway, thank you very much for watching. Really hope you enjoy these videos, and I hope this one's helped you think about whether you want to go electric with your heating system. And if you're trying to decide air to a water-based system, I hope this one helps as well. Air to air suited us. It was the right system, the right solution for us, and I'm really, really glad that I went for it. As always, thanks for watching everyone. Hope you enjoyed the video, and if you did, don't forget to click like and subscribe for more videos. More content coming, updates on all this great technology and how we're getting used to it and getting the best from it as well. So thanks again for watching. Take care. See you again soon. Bye for now. Merry Christmas, everyone.